we need to rearrange this. Okay, e x y minus ln z minus x minus y equal to 0. Okay, therefore we can define this as f x y z, which is equal to e x y minus ln z minus x minus y. Okay, so we want to find del z del x, so we can use the formula of negative, the partial for x y z over partial derivative for z x y z. And also if you want to find del z over del y, so we have the formula of negative fy x y z over fz x y z. Okay, so now we need to do it one by one. Okay, let's try the fx first. Okay, which is equal to, okay, so we need to differentiate partially with respect to x, the exy, okay, del x, the ln z, the x, and the y. Okay, so we know that if we differentiate partially with respect to x, so y and z will be constant. So now here, so exponent xy, so we need to multiply with the differentiation of xy, which is y lah. Okay, so minus ln z is a constant. Okay, minus del x is 1, minus y is a constant 0. So we will obtain e xy, y e xy minus 1. Okay, so for fy, okay, fy pula, okay, del y e xy, del y ln z, del y x, del y y. Okay, so this time we differentiate the exy, which is exy, and we need to differentiate xy. We will obtain x, okay, minus ln z constant, x constant, dy 1. So we will have x exy minus 1. Okay, so now next one is fz. Okay, so del z exy, del z ln z, del z x, del z y. Okay, so this one exy constant, ln z. Okay, so we need to differentiate z, which is 1 over z. Differentiate x, kosong. Differentiate y also 0. So we'll obtain negative 1 over z. Okay, so when to find del z del x is equal to, we use this formula just now. Okay, negative fx is y e xy minus 1 over fz is negative 1 over z. So we can simplify, we will obtain z. Okay, cancel out negative, so we'll have z y e xy minus 1. Okay, so for del z del y, okay, we can have del z del y equal to negative fy is x e xy minus 1 over fz is negative 1 over z. Okay, so again we can simplify, we obtain z as e xy minus 1. Okay, so this is the answer. Okay, alright, let's try the next example. Okay, so it's already equal to 0, therefore we can define the f as yz as the cos x plus 2z plus 3y squared ln y plus 2xyz. Okay, so we want to find del z del x. Again, the formula is negative fx over fz, and I just short form here. So del z del y, which is negative fy over fz. Okay, so this is our formula. Okay, so we just need to find, one by one. Okay, so fx is equal to, okay, so del x cos x plus 2z, okay, plus del x 3y squared ln y plus del x 2xyz. Okay, so for cos, differentiate the cos, we will obtain negative sign. So negative sine x plus 2z. So we need to multiply with the differentiation of x plus 2z, which is 1 lah. Okay, plus, okay, 3y squared ln y is a constant, 0. So plus differentiation of 2xyz is 2yz. So our answer is negative sine x plus 2z plus 2yz. Okay, now I want to find fy. Okay, so it's equal to del y. Okay, the same thing, x plus 2z plus del y 3y squared ln y plus del y 2xyz. Okay, so cos x plus 2z is constant because no y here, so cos 0. Okay, so 3y squared ln y, this is product rule that we can use. Okay, so 3y squared multiply with 1 over y plus 6y multiply with ln y. Okay, this is the chain rule. Okay, plus 2xyz. Okay, del y, so meaning that we'll have 2xz. Okay, so this is, okay, so we can cancel out this. Okay, so 3y plus 6y ln y plus 2xz. Okay, that one is for fy. So for fz, we will have del z cos x plus 2z plus del z 3y squared ln y plus del z 2xyz. Okay, so we will have 0 plus 0 plus 2xy. So find okay, so we will have 2xy. Okay, so now we just need to substitute into the formula, okay, which is del z del x is equal to negative, okay, negative sine x plus 2z plus 2yz over 2xy. Okay, alright. So for del z del y, so we'll have negative fy. Fy is 3y plus 6y ln y plus 2xz over 2xy. Okay, that is the answer.